Hello everyone, welcome to my channel Just in 2 Pages. Today in this video I am going to discuss about the designing of a shaft and mainly the numericals based on it. So we will see 2 to 3 numericals based on it. But before beginning of the numericals, I would like to write few formulas for you guys so that you can learn it in future. So the first and the foremost formula is M upon I is equal to FB upon Y is equal to E upon R. So here in this formula, M stands for bending moment, which is the product of force into the distance, that is the length of the beam. Next is I. I is nothing but moment of inertia, which is the sum of the product of mass into distance of each particles from the center of gravity. Next is FB. FB stands for bending stress. Next is Y. Y is the maximum distance of outermost layer from neutral axis. E stands for modulus of elasticity and R is the radius of curvature. Further we can also write FB is equal to M upon Z, where Z is the section modulus. So for rectangular section, Z about x-axis will be BD square upon 6, and for about y-axis Z will become DB square upon 6. The last one is for circular section, Z will be pi by 32 into D cube. So we will use these formula for solving numericals based on it. The question says that design a beam of uniform rectangular cross section which is fixed at one end and carries an electric motor wing 400 Newton at a distance of 300 millimeter from the fixed end. The maximum bending stress in the beam is 400 Newton per millimeter square and the depth of the beam is twice that of the breadth. So from the question we notice that the beam is of rectangular cross section. So here the moment of inertia that we are going to use will be of rectangular section. Further, the weight of the motor is given, that is 400 Newton, and the distance is 300 millimeter. So with the help of these two, we are going to find out the M, that is bending moment. After this, the maximum bending stress, that is FB is given, which is 40 Newton per millimeter square. And one more information is given in the question, and that is depth of the beam is twice that of breadth. So we can try to write it down on a sheet of paper. So we'll come to know that F is given as 400, D is given as 300 millimeter, and D is given as 2B. So here by using the formula F is equal to M into D, we can calculate the value of M, that is 400 into 300. It will comes out to be 1.2 into 10 raised to the power 5 Newton millimeter. After this, we can use the formula for inertia, that is BD cube by 12 for particularly rectangular section. So we also know that D is equal to 2B. So replacing D with the B, will come to know that I is nothing but 2B raised to the power 4 by 3. Now by using the formula M upon I is equal to FB upon Y, we know that M is given as we have calculated already 1.2 into 10 raised to the power 5. Further FB is given as 40. We have calculated the value of I, 2B raised to the power 4. Now here Y is nothing but B and B is nothing but as the distance, that is the breadth. So by putting all these value, the value of M, the value of I, the value of FB and the value of I, we'll come to know that B is nothing but it is 16.50 and D is 33. So here we'll choose the larger one, that is D. So that is the answer.